2011 higher level question. Intersection and development of surfaces. Let's look at the question. Now in this question we're going to use the cutting planes method to solve. The question states a 3D graphic of a trophy for an archery competition is shown on the right. The trophy consists of a number of intersecting solids. Figure B1 below shows the incomplete projections of two of the solids which penetrate each other. Part A. In a diagram, an irregular base pyramid rests on the horizontal plane. Draw the plane and elevation of this pyramid. Part B. An equilateral triangular prism of 40mm sides penetrates the pyramid as shown. Draw the outline plan and elevation of this triangular prism. And part C. Complete the drawing showing all lines of interpenetration. Let's begin. We begin by drawing an XY line, and now we draw our solid in the elevation. We project down from elevation to plan to give us our irregular shaped pyramid in plan, like so. Now we can extend out the edges of the triangular prism in plan, like so. Now we can join up our points in plan back to the apex, like so. Now we need to locate the position of the intersecting prism. We begin by drawing a line set at 22 degrees as shown, and now to locate our height of the prism we need to draw a line of 40mm in distance. We do the same on both sides. This triangle located here is the true surface of the triangular base prism. Now we can project down our lines like so until they meet the horizontal plane, the XY line. And now we can locate our surface in elevation, like so, and the end where the prism touches the XY line. We project down our points from elevation of this prism onto a plan, like so, and like so. We can now draw in elevation the true lines of interpenetration as shown. Now at the end of the intersecting prism in the plan we can connect up our points as seen. Now we can locate where this part of the triangular base prism is in plan, like so. This red line indicates where the apex must lie upon in plan. We can also do the same at the front of our irregular prism, like so. This is the apex of the prism here, and here it is located in plan. We can connect up our points in plan, like so. Now we begin by taking our first cut. This yellow line indicates a cut which will be taken from this point where the triangular based prism intersects this irregular based prism. Our points can be located on this edge here, which is here in plan and also here in plan. Therefore, this is a point and this is a point. We connect back this line in the elevation back to where it intersects the same point in the back part of the prism. We now project down this plane, which would be an inclined cutting plane, down onto plan to locate 2 points here, A and B. This helps create piercing point here and here, which helps solve the back end of the intersection here, which is here in elevation. Now we need to locate where the prism intersects in the front part of the irregular base prism. So we take a line, which this green line indicates here, cross from the center of the irregular based prism till it meets the outer generator of this prism, and we can drop this point down onto plan like so. Now we know that this point cannot be brought back horizontally. It must be brought back parallel with the outer edge of this prism. This will help locate the cutting plane at which this yellow line indicates in elevation. So we can drop down our points to both extreme generators of the irregular based prism in plan, and we can project back to create 2 more points, E and F. The yellow line also gives us another 2 points. So now we have a total of A, B, E, F and C, D. This helps to show where this cutting plane would actually be in plan, and we can join back the yellow lines in plan to show where it cuts. So within this area here, all the yellow lines shows the cutting surface of this simply inclined plane. Now we can project our extreme generators of this triangular based prism to where they meet this cutting plane, as this is where the bottom surface of the triangular based prism intersects the irregular base prism. Now we must locate where this apex and this surface here, which is hidden in elevation, is, to help locate the turning points. So we connect up this triangular here in plan. This shows what this surface here would look like in elevation here. We can connect up where this wine line here and wine line here crosses the 2 generators in elevation here, like so. We have now located the turning points. We now add in the hidden detail and project up our lines from plan into elevation like so, and add in all the hidden detail. Finally, there's the question solved.